Let's look at this previous question from the topics limits, continuity and differentiability. It's slightly involving, not a lot, but such questions are very much expected in the examination. So it's a very important model. So we'll discuss about, we'll first understand what continuity is. So for continuity to exist, first of all, limit has to exist. That means if I say f of x is continuous at a, then limit x tends to a, f of x should exist, let that be L, right. How does limit exist? The right hand limit at x equal to a, like right hand limit of a and left hand limit of a of f of x at a, like left hand limit of f of x at a and right hand limit of f of x at a should be equal, right. Or what I mean to say is f of x limit x tends to a minus should be equals to f of x limit x tends to a plus, like from both sides you should get the same value L, then I will say limit exists. And so this is the first condition. The second condition is f of a should also be L, right. For limit to exist, this second condition is not necessary, but for continuity to exist, for limit to exist, this first condition is sufficient, like this condition is sufficient, but for continuity, this condition, which essentially means this condition, and the second condition that f of a should also exist and that should be equal to the value of the limit, if these two hold good, then I will say it is continuous. And how about differentiability? So first of all, if the function is continuous, it has to be continuous only then. If it's not continuous, I don't need to evaluate anything else, but if it's continuous, it can be differentiable, right. The second condition is your f dash x is actually nothing but limit f of x plus h minus f of x divided by h, h tends to 0. This limit should exist. I've written some weird expression here, but it's very simple to understand this. This limit, like simply you have a function, write x plus h of that function, subtract f of x from that by h tends to 0, this limit should exist. This limit should exist. Like h tends to 0 minus for this expression and h tends to 0 plus for this expression should give you the same value. If that happens, I will say it is differentiable. So in short, if limit exists, this is limit, continuity, differentiability. If it's continuous, I can say limit exists. If it's differentiable, I can say it is continuous, right. But limit exists doesn't mean it has to be continuous. It will be continuous, right. So it's something like this. First of all, if it is continuous, limit has to exist. So it's like something like this: differentiability, continuity, limit. For this to happen, this has to happen. For this to happen, this has to happen, right. But it doesn't mean that if that happens, then the other will happen. So it's something like that. So it's actually better that if I tell you through the problem. So let's actually see. If at all I'm talking about differentiability, and the function is not continuous, if the lower condition is not satisfied, the upper one will not be satisfied, right. The upper one will not be satisfied. But if the upper is satisfied, I can definitely say that the lower exists, because only if the lower satisfied, upper will be satisfied, right. Something like that. So let's discuss about this problem now. So it's slightly involving. So I will only talk at x equal to 0 first. So at x equal to 0, if you look at this function, what is f of 0? It is 0. It's given in the problem that it is 0. F of 0 is 0. Now coming to what do you say? Limit. So let's look at limit x tends to 0 minus limit x tends to 0 plus. For limit x tends to 0 minus, I'll have to take this function. I can't take this. And if your x is less than 0 minus, that means if your x is negative, mod x will be minus x, right. So you will have x into e power minus 1 by x plus 1 by x, which is e power 0, which is 1. So it is actually x into e power 0. So it is, and when I put 0 in this, it will be 0, right. So left hand limit is 0. Coming to right hand limit, if your x is positive, your mod x will be x only, right. So it's simply this: x into e power minus of 1 by x plus 1 by x. So e power 2 by x, x into e power minus 2 by x, right. So what I'm doing here is I'm when I put x equal to 0 plus in this will be 0 into e power minus 2 by 0 plus. So this quantity will also give you a 0 and this quantity will also give you a 0, right? So ultimately what you'll get is a 0. So left hand limit equal to right hand limit equal to 0 and f of 0 itself is also 0. That means all these three are there. So it is continuous at x equal to 0. Only at x equal to 0 I need to check in fact. For other functions, if your x is not equal to 0, this function by itself will be continuous. So I only had to verify for x equal to 0. So what are the options eliminated? Discontinuous everywhere is eliminated because it is continuous at x equal to 0 and everywhere else, right? So neither differentiable nor continuous, this option is eliminated because it is continuous at x equal to 0. Now the only thing that I need to check is if it is differentiable at x equal to 0. If it is differentiable at x equal to 0, then it will be differentiable for all x, right? So option A will be right, but I need to check for x equal to 0 what it is. So if I need to check the differentiability, I need to check the limit of this value. So f of x plus h. So I need to check basically f dash 0. I need to check the limit of f dash 0. So what I'll do is limit, I have to verify this limit. So first I'll verify, if I need to verify this limit, I'll verify its left hand limit first. So left hand limit is limit h tends to 0 minus f of 0 plus h, right? So h is tending to some negative value minus f of 0 divided by h. And now I'll verify the right hand limit also, right? So for right hand limit, h tends to 0 plus f of 0 plus h minus f of 0 by h. If these two are equal, I will say this limit exists and then I will say it is differentiable at x equal to 0. If it does not exist, then it won't be differentiable. So let's see what we get. So f of 0 is simply what is f of 0? It is simply 0 because at x equal to 0 it's defined to be 0, right? So you simply have f of h by h, where h is some negative, tending to some negative value, right? So I need f of h, which is tending to some negative value. So that means I'll use this function, and if your x is negative, then this part, what will it become? It will become 0, right? It will become minus x. So what you'll have is x into e power minus 1 by x plus 1 by x, because your h is tending to negative value, some negative value, right? I'm putting some negative value in this function. So this will become minus x, this will cancel. So finally what you'll have is e power 0. And this value is somewhere very close to 0, right? So when I put x, I'll put a 0 here, right? It's some value which is very, very close to 0. So you have 0 into 1, which is 0. So the value for this expression is 0. Let's look at this expression. So for this expression, right hand limit, what I'll use is f of h. I'm sorry. You also have this. So you have x into e power 0, which is 1, divided by h. So you have x by h. You also have a by h here. I forgot about that. So both are tending to zeros. Like both are taking the 0 by 0 form. So I have to apply L'Hospital's rule, and then I'll get a 1 by 1, right? I'll get a 1 by 1. So in fact, I'll have an h by h. It's an h by h here, so it's 1. So the limit here is not 0, it's 1. But how about this? How about this expression? For this expression, what your h is tending to 0 plus. So this part is anyway 0. I need f of h by h such that your h is tending to 0 plus, right? So if it's tending to 0 plus, this value will be plus x, right? So finally what you'll have is x into e power minus 2 by x divided by h, and your limit h is tending to, x is tending to, or h is tending to 0, right? So basically you're putting an h here, replace all the x's by h. So this will get cancelled, and you have e power minus 2 by h, and your h is tending to 0 plus, right? It's tending to 0 plus. So this part will be a very, very huge value, e power minus a very, very huge value, which will be 0, right? So ultimately you'll get a 0 here. So here you got a 1, here you got a 0, and they are not equal. So I will say limit does not exist. If this limit does not exist, I will say it is not differentiable at x equal to 0. So it is continuous everywhere, but not differentiable at x equal to 0.